Hello everyone, hope you are all fine. Today we will start with a new lesson that is part of grade 9 curriculum. Its title is Optics. When you heard the word optics, you probably thought of shops that sell eyeglasses. Well, you're almost right, because optics is a branch of physics that studies sight and the behavior of light. At the end of this lesson, you will be able to recall what light is and describe its propagation, list the uses of lenses, differentiate between converging and diverging lenses, identify the different elements of each lens, and describe the pathway of some light rays passing through the lens. First, let's discuss what light is. Light is a type of energy, and as you know, there are many sources of light. Some sources are natural, such as the sun, while others are artificial, such as candles and lamps. The following experiment is performed in order to study propagation of light or how light travels. A straight tube is placed between a candle and a boy. Light is able to reach the boy's eye. However, in the second experiment, a curved tube is used. Light is not able to reach his eye. So we can conclude that light travels in a straight line when it moves in a homogeneous, transparent medium. Let's start with the next part of the lesson. Of course, you've heard the term lens before. But where do we find lenses? Well, you're actually right. Lenses are found in microscopes, telescopes, cameras, eyeglasses, and many other tools. Lenses are important because they have many uses. Lenses can be used to magnify objects like cells, or to view far-away objects like stars and planets, or to correct vision. But how do lenses actually work? When light hits a lens, it will change its direction. That's why a bigger or smaller images are formed. So a lens is a curved, transparent device that changes the direction of light. Keep in mind that there are several types of lenses which differ by their shape. Observe the following figures well. How can you classify these lenses according to their shape? If you have noticed, the first group of lenses has thin edges, and these lenses are thick at the middle. These are called converging lenses. However, the second group of lenses has thick edges, and these lenses are thin at the middle. These are called diverging lenses. In application 1, you are supposed to classify the following lenses into converging and diverging lenses. Don't forget to pause the video. So lenses 1 and 4 are converging because they have thin edges and are thick at the middle, while lenses 3 and 2 are diverging lenses because they have thick edges and are thin in the middle. Converging and diverging lenses also differ in the way they change the direction of light. We will start first with converging lenses. This is the symbol of a converging lens. Pay attention to the shape of the arrow. When two light rays that are called incident rays hit a converging lens, they will deviate to meet at one point. The light rays that emerge or leave from the lens are called emerging rays. So a converging lens deviates the rays to meet at one point, and they are mainly used to magnify objects. When we study lenses, we use ray diagrams. A ray diagram shows the symbol of the lens, L, the optical axis X'(X) that cuts the lens L at the middle. The lens and the optical axis meet at the optical center, which is O. The image focus, or F', is the point at which the light rays converge or meet. F' is placed after the lens. The symmetry of F' with respect to O is called the object focus, or F. So OF is equal to OF'. The distance from O to F' is called the focal length, and its symbol is a small f. Each lens has a different focal length. In application 2, you are asked to copy and label the different parts of the converging lens and to complete the path of the incident ray. Don't forget, the emerging ray will cut X'(X) at F'. This is the symbol of a diverging lens. Notice that the arrow is upside down. When light rays hit a diverging lens, they will deviate away from each other. So a diverging lens scatters light rays, and it's mainly used to diminish objects or make a smaller image of them. Similarly to a ray diagram of a converging lens, first we draw the symbol of the lens L, then the optical axis X', and the optical center O. However, the image focus F' of the diverging lens is located before the lens, and the object focus F is after the lens. Don't forget that OF is equal to OF'. Now, any light ray parallel to the optical axis of a diverging lens will deviate away from the optical axis, seeming to pass through F'. Don't forget that the focal length small f is equal to OF'. In application 3, you are asked to copy and label the different parts of the diverging lens and to complete the path of the incident ray. Don't forget to place F' before the diverging lens and notice how the emerging ray deviates away from X' or X, seeming to pass through F'. Now we will discuss the pathway of different light rays after hitting a converging lens. Notice in the first case how the incident light ray is parallel to the optical axis X' or X. This incident light ray will leave the converging lens passing through F'. So, any light ray parallel to the optical axis emerges or leaves the lens passing through F'. However, in the second case, the incident light ray is directed towards the optical center O. This light ray continues straight without any change in its direction. So, any light ray passing through the optical center continues without deviation. However, in the third case, the incident light ray is directed towards the object focus F. This light ray emerges from the converging lens parallel to the optical axis X' or X. Then, any light ray passing through the object focus continues parallel to X' or X. In the case of a diverging lens, a light ray parallel to the optical axis X' or X will deviate away from the axis, and it will emerge from the lens as if it's passing through F'. So we say that any light ray parallel to the optical axis seems to be issued from the image focus F'. Similarly to a converging lens, any light ray directed towards the optical center O will continue without any deviation. In the third case, a light ray that is directed towards the object focus F will continue or will leave the lens parallel to the optical axis. Observe the figure well. So we say that any light ray directed towards the object focus emerges from the lens parallel to the optical axis X', X. Now copy and complete the pathway of each light ray and justify your answer. To check your justification, please refer to the previous 2 slides. After studying the notes very well, please practice drawing ray diagrams. I will be sending extra exercises later on through the week. Hope to see you soon, and don't forget, stay home, stay safe.